next talk is titled Looking Through Muddy Waters, Insight into TTPs of a Mobile Eastern Threat Actor. Please welcome Jaromir.
Hello. So I will start my presentation about the muddy water threat actors. This threat actor, it's like APT group, and like I work as APT researcher, so I've been tracking them with also some of my colleagues for some time, and now I would like to share you like some results which we got. So this is the outline of my presentation. So this is what I plan to tell you within the next 30 minutes. So after the introduction, I will say like a little bit about the infection vector, how the threat actor spreads their malware. Then we will talk about these delivery methods. Then the threat actor implemented several backdoors, and they're custom, their own backdoors, so it will be like the next session. Then we will continue with the post-exploitation tools. They have some mobile malware, so I will talk about these mobile malicious applications later, some false flags. Then I will continue with the infrastructure, then who are the targets and victims, and in the last part, I will mention like some of the attackers' mistakes, like which helped us maybe a little bit to track them. So as the introduction, the first, like when this threat actor appeared, like there have been like several blog posts starting from the second half of the year 2017, and it continued throughout the year 2018 and also a lot in the beginning of the year 2019. So they have been developing a lot, making many changes, and we have been tracking them for some time. So on this slide, there is just a list of few blog posts which either we or some other researchers published. The list is not complete, like there have been like much more research. So when you just search for the muddy water keyword, you'll probably find like many other posts. So what is the infection vector? Like how this threat actor spreads their malware. So the infection vector is not surprisingly spear phishing. So they send email with some attachment to the victims. And usually, if for example they try to target some victim in one country, they used compromised emails from some other organizations in the same country, so it looks less suspicious. So they sent email. This email contains some attachments, and this attachment contains some macros. So these are the screenshots of these emails. So you can see like one screenshot on the left, another one on the right, and you can always see there is like some text, like dear company, we do something. In attachment, we send you something else. And what is the attachment? Like there are like different cases. In one case, in the left one, there's like zip archive, which the victim downloads and opens, and there is the document with macros. In some other cases, like in the right one, they include just the document itself. There's like no archive, nothing. Also like few more cases. In the left one, they use like a RAR archive. In the right one, it's like some docx, document X file. And if you can see, like it's like here blurred because of some confidential information, but in the right case, for example, there is the extension of the email .gov.jos. It's like some kind of government organization in Jordan, in the Middle East. There will be like many more cases. So the first step is that they send email with some attachment. And how this attachment looks like, how these documents look like. So they have like different, they sent like different documents, and these documents try to impersonate like organizations from many different countries. So here in this list, you can see the list of the countries which have been impersonated. So you can see like many of them, and this is the way how the documents look like. So we have like some text, which is like some document which is blurred, so it's like not very clear who is it or whom or from where it was taken. And in the center of the document, you can see the blue area asking like, please enable macros or enable content. So these are the styles of the documents. And usually these documents look very similar. Like this one is targeting like Republic of Azerbaijan, like Ministry of Internal Affairs, Republic of Azerbaijan. This one is impersonating like some other different organizations from different countries, usually from the Middle East. This one impersonates the National Assembly of Pakistan. This is something in Turkish. In this another case, it used to look, or it tried to appear like some CV, like for some job application. This one was quite interesting. It was sent to some organizations in Turkey after there's been some problems or some decisions like not buying these F-35 fighters. So there have been some kind of like problems like that, and they've used this opportunity to try to spread the malicious malware too. So what will happen after the victim enables the macros? So there have been like many like different delivery methods, and this has been like changing all the time. So here in this slide, I try to summarize what happened. So in the left, you can see the year and month, and on the right, you can see like the different, like the evolution of the malware itself, or of the dropper of the malware. So it always starts with macro, with some short exception of template injections, like in the April of 2019. And then this macro usually drops some files. There are usually scripts like Visual Basic script and JavaScript, sometimes binary files. And then it, via some decoding, via some process, it decodes to some PowerShell backdoor, which is their custom implemented backdoor, and there have been like several different versions. If I do the visualization in this kind of schematics of one of their campaign from November 2018, so you have the malicious macro, it drops some files. In this case, it imports some registry data into the registry, which establishes the persistence, so it gets run on the startup. Then this DLL file runs another obfuscated PowerShell code, which after the obfuscation connects to the CNC server. And another case, again from November 2018, which I will do in this schematics. So it downloads some PowerShell code, it drops like 3 different files. The first Visual Basic code runs JavaScript obfuscated code, which decodes and runs base 52 encoded code, which becomes PowerShell backdoor, which then connects to CNC server. One more delivery method which we found were the Trojanized keygens. So there is the known tool called Burp Suite, and we found a keygen written in Java, and this keygen was Trojanized. So you can see the highlighted lines that after running the keygen, it dropped some files, and it was like one of these like muddy water threat actors backdoors. Before I mentioned like base 52 encoding, which is like very untypical for threat actors. They usually use like typical like base 64, but in this case we found base 52, and with untypical alphabet. You can see in the center of the screenshot there is the long string starting with left bracket, right bracket, star, plus, minus, numbers, letters, and this is the alphabet. It has 52 characters, and this is the way for how they encode their payloads. So we mentioned this like in one blog post. It was like almost like 1 year ago, and after that we noticed that they changed it a little bit. We have noticed some instances where this alphabet was shorter, like base 45, base 48, base 40. So it seems that this threat actor is like reading. They're looking online like who publishes what among them, and they just change their malware based on this or make some changes. So now let's talk about these backdoors and post-exploitation tools. So the main backdoor, which they have been using for most of the last year and since the beginning basically, so for most of the time, it was called PowerStats. It's like standard backdoor with the main features for downloading, uploading files, taking screenshots, and so on. The interesting is the screenshot in the middle, that there is like one command called muddy. And this is the way why this threat actor was called by the researchers like muddy water, because like it's like one command which they send from CNC server starting with this keyword and then executing the command after the muddy text. So this PowerStats backdoor is written in PowerShell, so it's not that difficult to analyze it, but there is lots of obfuscation. There are like many layers of obfuscation. So you have like, in some cases, even 10, 20, 30, 50 layers of obfuscation. So it takes some time just to remove all these obfuscations until we get the code of the backdoor itself. And these are the techniques used for this obfuscation. So it's like different techniques like base64, zlib compression, invoke expression commands, and so on, some randomized named functions, and so on. This backdoor communicates with CNC server. It creates like JSON objects. It encrypts them and sends them to CNC servers. And this is the way how communication is done. And it's not done directly to CNC servers, but it's done through proxies. And this is the message what I got like in one case when for some reason I patched the backdoor and it didn't encrypt the code. So I sent them the data and the response is here. You can see in the screenshot, stop, I kill you researcher. So this is probably like another case when I noticed that they're like monitoring like what's going on and they try to see like which researchers try to track them and what they try to do. So after the first backdoor, we noticed like different backdoor called CloudStats, which was quite interesting because it uses Dropbox for like the communication. So they upload like some file to the Dropbox, the backdoor downloads it, executes the command and uploads the result back to the Dropbox. And you can see there are like some different extensions of the files. So for example, if the file is .rec, it's like the registration information which is sent from victim to the CNC server. .cmd, malware botnet operator uploads to Dropbox and the victim machine downloads it, executes it, and .ris result is the result of the command which is again uploaded to the cloud. It was quite interesting. And of course they have the API tokens, access tokens, and after reverse engineering you can obtain it and you can monitor them like what commands are there if they haven't been deleted. Then we found like another two backdoors. One was called SharpStats and another one which will be on another slide called DelfStats. These backdoors were quite simple. They implemented like only the basic features for downloading, uploading, and running commands. And partially they were written in different languages, like either .NET or Delphi. And some of these routines were done by PowerShell. So some PowerShell script was dropped, executed, and the result was read by these backdoors and uploaded to the CNC servers. Then we noticed version 2 of the PowerStats backdoor. This was again like written completely in PowerShell, lots of obfuscation, and basically there was just the simple like main function which did like hello message to the server, then get the response like what command should be executed, then it executes the command, uploads the result back, and it continues like again and again. Then there was like update to PowerStats version 3, which was again like kind of similar to the previous case, but in this case, the basic backdoor implemented only few commands like taking screenshots and running command, running command. But then more functions were implemented in another stage. So the backdoor was split into two stages, and the second stage was only like sent to the victim if it was interesting for threat actors. We also found like, except for these custom backdoors, which they wrote by themselves, we found like some of the frameworks which are like generally available on GitHub or on internet, and they've been also using them in like some of their operations. So these include, for example, like Meterpreter, PowerSploit, Coadig, which is like a framework in JavaScript, written in JavaScript, Empire Project, and also like a few more tools, like for example, SMB maps for mapping SMB shares, credential stealing tools like Mimikat or Lasagne. The Lasagne is quite similar. You can see the screenshot on the right that they took the lasagne code from GitHub and they added like one function called inti mod dumpers, not init, but inti. There is like a typo. And this one included the function which again dropped the power stats backdoor. It's kind of a similar case like in the case of patched keygen, which I mentioned in the beginning. So they did this kind of patching. So now let's continue and look at the malicious Android applications. So for mobile applications, we haven't found much data. We just found 4 samples. And you can see the name of the sample and timeline on the left. So the first and last case, like AndroRed and DroidJack, they're like kind of the commodity malware which can be downloaded from internet. And the second and third case were some kind of custom. The first one was the custom file stealer using Telegram as CNC channel. It was like their customly written malware. And there was also like one other case with kind of traditional CNC communication, not using any cloud services or any messengers. In this screenshot, you can see like for their custom malware, there is the class called like my protocol or application protocol, and you can see like the list of features like on the left and on the right. So the names on the left can be found in the subset, are the subset of all the commands on the right, but the list is like extended, so it's likely that, or it shows that there's been like some development like between the second and third version. So as I mentioned before, like we don't know much about these like Android applications, but there are like few either file names or few metadata which we managed to collect. So the one of these applications was called like Afghanistan election.apk, so probably targeting someone in Afghanistan, in Middle East or South Asia or in this area. In one other family, they contained some IP addresses in Pakistan, which they try to brute force it. There was the brute forcing function. Like one of this malware family was spread via sending SMS messages. I will show later the screenshot. And one of the sample was distributed from compromised Turkish like non-profit research website. And here are the screenshots like for sending the SMSs. So the SMS was in Turkish, and on the screenshot below there is the link to some APK files. So it asked the victim just to download and install some malicious mobile application. Now I will talk shortly about the false flags, infrastructure, and the targets. So this is like what I mentioned like before, that like one of these backdoors had many layers of obfuscation. So after deobfuscating all of them, we were present with these kind of messages. Like this one, there was some text in simplified Chinese, and the translation was saying like, unable to connect to URL, please wait for Dragon, for some reason. So it was some kind of like error message. So they probably tried to, confuse some, I don't know, beginner researchers to think that maybe they come from mainland China and try to target someone. Or also in the same sample, like one variable with the list of proxy servers, again obfuscated, but after the obfuscation we got like the URL addresses. The variable was called like Dragon middle, like referencing to Dragon, maybe again China. In another case, there have been like few messages in Hebrew. There were like in the backdoor there were 2 variables which were not used, so they were like totally useless. One was called $God, the second one $SKey, and over there you can see the translation if you translate it to the English. So there's like one message was like some kind of quote which was said by I think the Israeli prime minister like maybe 10-15 years ago, and the second one was some kind of like religious message, so related to Israel for some reason. Also another false flag have been related to Russia. They were using Cyrillic alphabet. So I mentioned that they spread their malware using the malicious documents, and these documents can have different metadata. So you can see there, like, there's like message like, or there is the name, or what is the name of user who created the document, and there is written in Russian like Pользователь Windows, like Windows user, or on the right part there's the creator, and in Cyrillic DSYR, or another artifact in one document, like again it's like C users DSYR / something else. So maybe like these kind of false flags. But we are sure that they are like false flags because it seems that this threat actor is based like in Middle East. So for the infrastructure, this is the list of, we found during the research, we've been monitoring them like for maybe 1 year or for quite long time, and we have seen at least like 37 IP addresses used as CNC servers, 4,000 plus compromised WordPress services. They have been acting as proxies. We found like different accounts for service providers, for DNS domain names, for dynamic DNS domain names, and so on. We also found like some code which was running on the backend as a CNC server, and it was the Python script. So we just found it, decompiled it, analyzed it. So this is how it looked. So this was the application version 1.0.0 running on the backend, and this had like kind of nice ASCII art like Muddy C3, and this is the list in the screenshot, the list of URLs which it implemented. So every time this CNC server was running somewhere, and if you connected to any of these URL addresses, you got like some results. I also mentioned here that they use some broken or some weak RSA implementation. So I'll talk a little bit later in the last section about the encryption. It was not very difficult to crack it. We also found like new version 1.0.1. It has like new ASCII art this time. It's like spider and the web in ASCII art. And if you see the list of the like implemented URL addresses, the last one is called modules. So probably the newer version like implements some modules, but we didn't manage to get any. So probably we might find it in the future. So now I will talk about the targets and victims. So who they are. So we found out that they have been like, from our monitoring, from metadata and from like other sources, we found that there have been like around 2,000 plus compromised hosts. We managed to identify like 60 of them, and this is like when we draw it on the map. So you can see that mostly it's like Middle Eastern countries. So most victims are there, and from these countries, like I would say that Turkey was the most targeted. But also there have been like few cases in Europe and US. So who are the targeted industries? So it was like mostly government, like maybe 2/3 of the cases. Telecommunication and IT services for another maybe 25%, and the rest was like transportation, gaming, few NGOs, food and media companies. When I say government, what I mean, so it's pretty much every ministry of government, Ministry of Finance, Education, Interior, Defense, law enforcement agencies, and so on. In April 2019, there had been like some leaks, like someone created the Telegram channel, and to this channel they leaked like some information related to not only like Muddy Water and to also some other threat actors. We found this leak, and this leak included screenshots which looked like these ones. So there had been like Muddy C2, and there had been like list of some victims and IP addresses and this information. So we looked into this screenshot and looked also to our monitoring, and we found that there is some overlap, that we have information about some of these victims as they have. So it seems that also we can say that these screenshots or these leaks are like legitimate. It's not like made up. That we also found the similar results. Now, like for the last part, I will talk about like some of these mistakes which the threat actor did. The first one was quite interesting because like we analyzed like these documents, as I mentioned before, and in one of these documents there was embedded this screenshot. So someone made, probably by accident, screenshot of his computer and by accident embedded it into this document, and we managed to find it. So in this screenshot you can see, if I make bigger the tab, you can see that there are like the second tab, import CSV go fish, and there is like some letters in Arabic or in Farsi. And the name of the user in this case was called like Turk, probably Turkish, someone targeting to Turkey. Arabic letters, go fish is some kind of like phishing toolkit. It's quite interesting. Second thing, like I mentioned that they used lots of proxies. So the whole thing looked like this, that there was some compromised proxy, there was the attacker victim, and the communication was done through these proxies, and only when the victim machine was instructed to upload some files, they were not uploaded to the compromised proxy, but to their final CNC server. But these proxies were not controlled by the attackers. So sometimes we found something like that, like there was the proxy, and there were like several files. Some of them had the length 0, but some of them had some content, and they were not clean, like not deleted. And after we looked into these files, these were the hashes, we could find, like you can see in the upper screenshot, that there is like the command with some IP address, port, /HTA. So basically this corresponds the path as we found, or as I mentioned, in this CNC server, in this CNC backend. So we found through this like several of these CNC addresses. Or the second screenshot, there's like base 64 encoded command, which after decoding again asks for some get command to download like some data from the server and execute it. I mentioned that there has been like the encryption, and this is how the encrypted traffic looked like. That there have been like lots of numbers, and they had only like 3 digits, like only 3-digit numbers, space, and another 3-digit number. And after reverse engineering, we found that these were the prime numbers used for encryption. For RSA, as you can see, it's like very small. For example, 959 is the prime, or 713. So if the prime number is very big, the factoring or factorization takes lots of time. But in this case, it's very simple to find the P and Q, and you can basically compute like everything and crack the encryption, get the key, and decrypt it. So the code below can become something like this. So in this encrypted data, which we like downloaded like from some of these like open proxies, we could see like the machine name, we can see the hard disk, hard drive information, IP address, name of the computer, name of the user, for example. And we could do it like for more victims. So this is the way how we could know like who was the victim. Also, like one more mistake are the open directories. So sometimes you go to the directory and there are lots of files. So I just download everything and analyze it. Sometimes it's very simple, like not all the time, but these are like few screenshots, which is nice for researchers. Like before I mentioned, like there is like one more like smaller mistake. I mentioned that they use Telegram, and for the Telegram channel you have some metadata. And if you see this language code, you can see that there's like FA, which is like Farsi language, which is spoken, I think, in Iran or somewhere. So of course it can be false flag, but it can also be the information which can give us the hint like where the threat actor is from, because they forgot to change it to English, for example. Yeah. So this is basically all like for which I present for my research. I would like to also mention like few or show screenshots of like few blog posts which I found, because for us as researchers, we usually don't do, or we should not do any attribution. It's like not our job. We mainly research like how the malware works and how the malware is spread and how it functions. But during this research, we managed to find like some individuals or some emails which might lead to some individuals. And if you look at for the information, there'll be like different blog posts. One was from group IB called like Mutnie Vody. It's like one blog post, like exposing some individuals. Another one ICNA, Iranian Cyber News Agency. They again mentioned like some of these links. Or one link, 0xFFF something blog, Muddy Water Cyber Spy. It's like some, I think, Chinese researcher. And they went even like farther. They even like exposed these people or the person who might be behind, which might be true, but it can also be false flag. So we have to be very careful with this. And now I see that my time ran up. So if you have any question now or later, I'll be happy to answer it. So that's all from me.
Any questions? Cool.
Yeah, it's very amazing.
Дякую много за супер презентацию. Thanks a lot for excellent presentation.
Thank you.
It was really interesting. One of the questions you already answered about the attribution. I think we all know that it's Asian faults, and it was also in the Telegram channel about Telegram.
Yeah, true.
I'm interested, like, is muddy water somehow related to oil rig, or is it the same faults? Because in the Telegram channel, they were dropping probably both of them in a way.
It's difficult to say. Like in this channel, they drop or they leak information about both of them. So they might be related. Like I personally don't know, and it's like very difficult to say. Like I prefer not to do any attribution, but they might be related. It's like difficult to say for me.
Thanks a lot. Any questions? I will ask one more.
So ask
Come
if
on, be ready. Get me across questions.
Nobody.
you can ask more.
The Chinese translation was quite funny. I guess they don't know much Mandarin or something like that.
Maybe they use just Google to translate it. I don't know.
I guess the Hebrew was quite okay.
Yeah, I think there's this Hebrew. If you just take exactly this message and put it to Google, you find the Wikipedia webpage with these quotes. So I think they just Google it and just copy paste it there.
Then I noticed that the Turkish was quite good.
Yes, they target a lot Turkey, and I think.
But Russian didn't make any sense. Sure, it's the letters you will not together on the.
To me, these Russian letters don't make sense either. But maybe they just install some virtual machine with Russian language. They just keep there some metadata and maybe try to fool researchers. It can be like one explanation, but again, like I don't know. These are false flags, so they can, if they are careful, they can put there anything.
And I think the blog post from that cyber file was deleted afterwards.
Which one?
The blog post from this 0x00 or something.
Was it deleted?
Yeah, I think so.
Because the guy whom they mentioned, I think he complained or something like that. But that's why I don't like to do any attribution. I prefer to research like how the malware works, how they spread it, but who is behind, like I have no way to find it out, so I prefer to avoid it.